So today I'm going to be teaching you about the difference quotient. Now the difference quotient is just a fancy word for slope, and most of you probably know what slope is. In mathematics, slope describes both the direction and the steepness of the line. So you're probably thinking, why do we have the difference quotient if we already have slope? Well, the goal of the difference quotient is to better understand and model the behavior of curves. So in order to model the direction of a curve, we need to know the slope of the curve. Normally, slope applies to straight lines only. When you think of slope, you probably think of like a slope, but the slope is actually the steepness of a line like this. So we also intend to expand to curves as well. So you guys probably know what a machine is, but I'm going to explain it to you anyways. A machine is something where you put in something and you get out something. That's the function of it, and function is the word we're going to use. A function is when you put in an input and you get out an output. So I'm going to show you a basic graph of how a function would be placed into a line. So this is a graph. And right here we have x, because you guys know that any given point on the horizontal axis will be represented by x. This guy right here is our function, and he's the function of x, which is basically y, but because it's the slope of a curve, it's really different. So now you can see the full graph, and you can see that it extends to the right, which means that x is going to get bigger and your function is going to get bigger. But we don't know how much bigger they're going to get. So we're just going to want to add h to this x and h to the function over here because we're not sure how much further it's changed. So now you're probably wondering, why am I looking at a graph with 2 points? Well, the difference quotient is going to show you the slope between the 2 points. And I'm going to draw it for you right now on the same graph that I showed you. That dotted line represents the difference quotient, or the slope between the 2 points. Now you guys know basically what the difference quotient does, so now we have to know how to use it and how it works. So now you guys are probably noticing that the dotted line doesn't even follow the slope. Well, we're going to fix that. The only difference between these 2 points is that this one adds h to both of them. So the more you move the points together, the better it is going to be for you. What's the smallest distance that you can move the points closer to each other? That's right, 0. 0 is pretty much means that they're the same thing. So like I said, the distance between the 2 points is going to be h, but now h is going to be 0 because we moved them all the way close to each other. Now I finally get to show you guys an example of how you can actually use arithmetic to figure this stuff out. And because difference quotient is just a fancy word for the slope of curves, we're going to use the slope formula to help us. Like I said before, the functions will work as our y's, and the x we already have on the graph you see here. X function, x function. So we're just going to plug those in. And as you can see, the fx plus h, which was our second y point, will go right there in place of the y2. And the first y point will be our regular function. On the bottom of that will be x plus h, which was our second x point, and x, which was our original x point. So you end up with this, but obviously you can cancel some things out, so I'm going to go ahead and do that for you right now. Right here and right here. So you guys see how there's a positive x and a negative x? Well, I canceled those two out, so now the denominator is just h. So this right here is the actual difference quotient, and it's f of x plus h minus f of x over h. That's how you're going to find the slope of a curve. Here's a real life example for you guys, just so you guys get the hang of it. We're going to start with this guy, x squared, and he's going to be our example. This is our function, and we're going to have to graph it. So the first step is to know the difference quotient again, f of x plus h minus f of x over h. So you're going to end up with x plus h squared because you plugged in the x plus h here, which basically just squared it, and you plugged in the x here, which just made it square itself. Your third step is to expand this guy out. So you basically use the distribution process and you square x plus h. So you get x squared plus 2xh plus h squared minus x squared because you already had an x squared right. And you're not going to want to forget to put the h on the bottom. So let's draw that right now. All over h. See that? But remember that we made h0 because we moved the points close together. So now we have to eliminate pretty much every x, or if an x has a power, decrease the power, and then we'll see what we get. After canceling out the h's, we also have to cancel out the terms that are negative and positive, which will be the positive x squared and the negative x squared. And now, after cleaning all of that up, we can finally get our final solution. So we end up with 2x plus h, which is going to be the difference quotient, or slope of the curve of our function originally, which was x squared. And that's all you need to know about the difference quotient and how it works. Thank you!